Hello everyone, welcome in our new video recording. We will explain the auto-reclosure function from the basic and technical background, the theory of operation, and we will take some examples and the definitions of the different times inside the auto-reclosure function for protection relay. So let us dive into the topic. So here is the auto-reclosure theory of operation. So the auto-reclosure function for the distance protection relay is mainly used with the overhead line. So one of the key targets of the power supplies is to keep the outage time as short as possible. So the practical experience in the power system has shown that more than 80% of the fault in the overhead line network are transient faults. It's not sustained faults, and they are commonly caused by the lighting surges, switching surges, swings wire, and temporary contact with objects, and so on. So after a short time de-energization, the arc extinguishes and the line could be reconnected or reclosed successfully. So for this purpose, the auto-reclosure function is used, and the principle of the auto-reclosure function is clearing the fault by momentarily de-energizing the line and fast reclosing of the circuit breakers in order to maintain the system stability and continuity of the service. But in cable network, faults are not self-extinguishing, and that's why the auto-reclosure function must not be used with the underground cables, and also must be not used with faults within transformers and generators, because the faults are not self-extinguishing. And as you can see from our screen here, how to reach the 100% selectivity of the protected line with the regular time grading, because the zone 1, which is the undelayed trip or the instantaneous trip, typically covers up to 85% from the protected lines. But how to cover 100% selectivity of the protected line with the regular time grading? It is desired to also cover this remaining part of the protected line with a fast trip. So we have two options to cover the remaining parts. Option number one, it can be achieved by using the communication with the relay at the remote end, such as tele protection communication schemes and so on. The option number two is to use when the relay with the AR function quickly switch on the line. So an overreach or a non-selective tripping is acceptable. So it can be done using the AR function, and that's what we will explain in the following slides. So here is the implementation for the auto-reclosure function with the overreach zone. So it can be used with the distance protection zone for the overhead lines. And as you can see from the figure here, it's the feeder connection diagram for the application example. Okay, so the auto-reclosure function can be used with the overreach zone. So in order to reach a fast fault clearing for the entire length of the overhead line using the distance protection with the AR function. So a controlled overreach in this case, which called Z1B, can be set to cover approximately 120% of the protected line and to enable the instantaneous tripping. And this Z1B can be represented here, as you can see, 120% from the line length, and also can be represented by the hashed lines in the circuit diagram. So the auto-reclosure functions, as you can see here, the protection relay takes the CT and the VT from the secondary side of the instrument transformers for the protection functions, such as 21 and 79. And 79 here is the ANSI code of the auto-reclosure function for a single AR cycle and 3 pole tripping mode. Okay, and also there is some binary inputs to take the status of the circuit breaker, such as circuit breaker on and circuit breaker off, circuit breaker ready, and many more. So here is the logic of the AR function. So the trip will be used with the distance trip, and here is the ready signal, which is taken by AND gate with the circuit breaker ready and the circuit breaker on. And circuit breaker ready, it includes the open close open cycle, which means the spring is, of the circuit breaker is charged and it's enough to achieve the OCO cycle or OCO mechanism. Also it includes the SF6 pressure of the circuit breaker, and also the circuit breaker on status is also needed for considering the AR function is ready. Also circuit breaker synchro check release in case of the life to live lifeline to live bus bar. Also the synchro check OK is needed to initiate and to make a successful auto reclosure. So here is the auto-reclosure logic types. So the type of operation, as you can see, it can be classified in by two ways: type of operating mode and also the type of operating time protection relay. So in the first type of classification, using the type of operating mode, we have two different modes: single-phase tripping and three-phase tripping. Typically, the operation mode depends on the type of the circuit breaker. Okay, so for the single phase tripping or single phase controlled circuit breakers, here is a typical example for networks higher than 110 kV. So the single phase tripping only for the first AR cycle with a short time, and it's not for phase to phase and three phase faults. Second type, which is a three phase controlled circuit breaker, it's typical for network lower than or around 110 kV. So a single phase tripping can be used for extra high voltage substation such as 380 kV circuit breakers, and the three phase tripping can be used for high voltage and medium voltage circuit breaker below 110 kV. The second type of classification, which is the type of the operating time. So the AR logic can be distinguished by the parameterized duration of the dead time, and the dead time here is the time between the drop off of the trip command of the circuit breaker and the circuit breaker close command. So here is the definition of the dead time. So we have two types. For short time auto-reclosure, the dead time depends on the voltage level for sure. So for voltage up to 110 kV, the typical times are 300 to 500 millisecond for three-phase tripping, and for the voltage higher than 110 kV, the typical dead times after a single pull trip are in the range of 1.2 seconds. The long time AR is only used when more than one AR cycles or AR shots are parameterized. So it's used typically such dead times are in the range of 60 seconds up to 120 seconds or 180 seconds. So it depends on the design and on the network topology. After a three pole trip, also a synchro check is required and for a successful auto reclosure. So after each AR shot or AR cycle, the circuit breaker need enough time to reconfigure, and for this purpose the relay starts the so-called reclaim time. So after the final close command, during this time the AR is not ready and it's not ready for any faults that occurs, so the relay trips in the regular distance schemes. So once this time has elapsed, which is the reclaim time, the relay would allow a new AR cycle or AR shot. So it mainly depends on the time being needed for the circuit breaker to perform a new auto-reclosure cycle. Now we will explain the auto-reclosure successful scenario with a short time. So as you can see here, the figure shows the zone and the time grading for distance protection, showing the overreach zone Z1P, which is a hatched area, as you can see from the zone and time grading graph here. So Z1B equal 120% from the ZAB or from the line length. As you can see here, we will explain one by one what happened in the auto-reclosure successful scenario. So first, as you can see, we have a short circuit happened in the line A and B. So the relay will pick up after 30 milliseconds, and it will issue a trip command during the action time. Okay, so here is the trip command of the circuit breaker, and once the trip is issued to trip the circuit breaker, the AR process is running and is initiated, especially if the fault is in our line, which means it's tripped by Z1, so it tripped instantaneously. So it may be a transient fault, not sustained fault, so we can initiate the AR. The protection relay will initiate the AR process to initiate the AR close command. So as you can see now, the circuit breaker is tripped and the AR is initiated in the same time. Then it will check the dead time. So suppose we have a dead time equal to 500 milliseconds. So it will circuit breaker will assess the circuit breaker status during this time, and it will issue a circuit breaker close command again, circuit breaker on, after elapsing the dead time. And then the reclaim time will be initiated after the circuit breaker close. Then to assess the AR is successful or unsuccessful based on the reclaim time. And after the reclaim time elapsed, the AR running process will be elapsed and it will be ended by the end of the reclaim time. So here is the time signal of the successful auto-reclosure, short time auto-reclosure for a single shot. Okay, so here is a first example. So now we will take just an example about the relay parameters for our application. And as you can see here, we have the auto-reclosure parameter setting for first cycle or only single shot, as you can see. So we have circuit breaker ready before the AR start is yes. The operation mode is a single pole tripping. The dead time equal to 0.5 seconds. The reclaim time equal to 3 seconds. And the action time equal to 0.3 seconds. Blocking time after the manual circuit breaker on is 1 second, and the line angle, short circuit angle equal to 64 degree. And we will explain the meaning of all of these times just to understand what's going on in the auto-reclosure logic. The first parameter we will talk about, which is the action time. So as you can see here, the action time is equal to 200 millisecond, and in this action time the relay should issue a trip command to trip the circuit breaker and to isolate the fault. So in the first scenario here, the relay has activated the trip command at the action time, and it's initiated the AR cycle, so all is okay. But in the second example, as you can see here, we have the short circuit happen and the relay will picks up, and here is the action time equal to 200 milliseconds, but the circuit breaker is tripped after the action time has been elapsed. Okay, so this will block the AR cycle because it's assumed that the arc has burned into such an extent, and there is no longer any chance of automatic arc extinction during the reclosed time. Okay, so here is the meaning of the action time, which is classified in our parameter setting for 200 milliseconds. The second parameter, as you can see, which is the dead time. Okay, so before automatic reclosing of the circuit breaker, a sufficient time period has to elapse in order to deionize the fault path. And this is called the deionizing time. So if not enough time is guaranteed for the ionized air or the ionized medium to discharge, the arc will be present on the re-energized or reclosing process. So the auto-reclosure or the auto-reclosing logic is unsuccessful. The deionizing time, whose duration is influenced by several factors, is the most important criteria here for setting the dead time in the protection relay. And as you can see from our graph here, you can see the dotted lines representing the deionizing time, and the solid line in blue representing the dead time. So here is the relation between the voltage and between the time in a scalar view. And here is the definition of the dead time. So the definition of the dead time, it's the time starting after the circuit breaker tripped until the circuit breaker ready to be reclosed again. So here is the dead time and the meaning of the deionizing time. Third parameter, which is the reclaim time. Okay, so for each auto-reclosure cycle, circuit breakers need enough time to be reconfigured. Okay, so the automatic reclosing is blocked during this period, which is called the reclaim time, and it depends on the breaker types. So different breaker types require different reclaim times. So let us explain the reclaim time. The reclaim time is the time between the circuit breaker first shot reclose until it's considered as successful auto reclosure. Okay, so in the first graph here, as you can see, we have short circuit happen, we have a pickup of the protection relay, then the circuit breaker is tripped during the action time, and then waiting for the dead time equal to 500 milliseconds, and circuit breaker reclosed at the first shot, and it will initiate the reclaim time to assess the auto-reclosure reclose. So it's successful or unsuccessful. So if there is any fault to happen during this reclaim time, the auto-reclosure will be blocked and it will be considered as unsuccessful auto-reclosure shot. Okay, but if the trip happens after this reclaim time, it will initiate a new AR cycle or a new AR process. So in the first example here, the short circuit happens at the end of after the end of the reclaim time. So there is a new AR cycle is started, and the trip time will be 0 second. Okay, but in the second diagram here, the short circuit happens, the relay picked up and issue a trip command for tripping the circuit breaker and isolating the fault. And after 500 milliseconds, the circuit breaker is on again by the first shot of the auto reclosure, and it's initiating the reclaim time. And as you can see, we have another trip which is a short circuit, happens again during the reclaim time. So the AR function will be blocked and it will be considered as unsuccessful. And the trip time in this case will be with a 400 millisecond, which is the trip time delay of Z2, the delayed trip time. So here is the meaning of the reclaim time, and here is different status of successful and unsuccessful auto reclosure. Okay, here is the auto reclosure short time or unsuccessful. Okay, so for the unsuccessful auto reclosure, the second trip gives a time delayed trip order. So in this case, with the trip time of Z2, which is the delayed trip time equal to 400 milliseconds. So here is the typical logic for the single AR cycle, but it's not always the case because it depends on the relay manufacturer. So as a function of the relay manufacturer, different relays gives a faster trip in case of unsuccessful auto reclosure, but the most common, it will be delayed trip time by Z2 400 millisecond. So the AR running, as you can see here, let us explain the time signal. So the short circuit is happening in the fault on our line, which means between A and B. And the relay picked up, and during the action time, it should issue a trip command to trip the circuit breaker and to isolate the fault. And here is the AR running process will be initiated with the first trip of the circuit breaker until the elapsed of the reclaim time. So here is the AR running time. Then, after that time, the circuit breaker will be reclosed by the first shot of the AR function, as you can see. Here is the circuit breaker on, and here is the starting of the reclaim time. But after and during this reclaim time, the circuit breaker facing a short circuit again in the same location, as you can see. So the reclaim time will be ended and the AR will be blocked, and the trip will happen with a trip time delay equal to 400 milliseconds, which is the Z2 trip time. Okay, so here is the process of the unsuccessful auto reclosure in our case. Okay, so the AR running here it's a signal stops the expiration of the reclaim time. So it's ended with the elapse of the reclaim time, and it depends on the manufacturer. So the second trip in this case will be tripped after 400 milliseconds, which means overhead line is definitely de-energized and the AR is plugged until the maintenance happen to the this overhead line. So here is the wiring to test the auto reclosure. So simply we need to connect the CMC voltage and current output to the protection relay analog input, as you can see. Also we have different binary inputs to be connected to the relay binary output to simulate different events such as the pickup, the trip, and circuit breaker on. And also we need to simulate circuit breaker ready, circuit breaker on status through the binary output of the CMC to the binary input of the protection relay. So here is a simple wiring diagram for testing the auto reclosure function. Okay. So we have a practical example how to test the auto reclosure function. So depending on the application complexity of the auto reclosure function, we have different approaches can be taken into consideration and can be used for testing. So without complex blocking or releasing logic, it can be tested with the test universe auto reclosure module. Okay. Also, it can be used and tested using the state sequencer module. So in the state sequencer module, you will have the total flexibility to create multiple cycle auto reclosure sequence with a complex logics. And also, the last but not least, it can be tested using the RelaySimTest software to simulate a realistic simulation with transient algorithm, which is automatically test the AR different cycles and different sequences. So we have here different test cases can be tested using the RelaySimTest software by using the iterative closed loop, or can be used also using the test universe auto reclosure module, dedicated module, or the state sequencer as a generic test module. Okay, so the AR function can be tested with the RelaySimTest and with the iterative closed loop feature. And this test is valid based on the assumption that the relay reactions are consistent in every iteration. So the relay reaction in the binary traces should fall within a given time tolerance compared to the previous run. So otherwise, the shot is assigned to error and the injection will be stopped. And this can be tested with 6 test cases. So the first test case, which is the AR successful sequence with dead time measurement. In this sequence, the fault will be was extinguished successfully during the dead time pause, and the AR is successful, which means there is no any trip happened during the reclaim time. So the AR sequence is considered as a successful AR in this case. The second test case, which is AR unsuccessful sequence with dead time measurement. So for this test, we want to simulate unsuccessful sequence of the AR function. So the unsuccessful means that the fault was not extinguished after the dead time pause, which means we will receive a short circuit fault again during the reclaim time. So the AR will be plugged, and it will be considered as AR unsuccessful sequence. The third test case is the AR not successful due to the time out of the action time. Here we will simulate the trip of the circuit breaker after elapsed the action time, which means the AR is unsuccessful. The fourth one, which is called 3A, the AR second fault within the reclaim time. So in this test, we will simulate the second fault within the reclaim time, and the AR function gets clocked by the relay, and the second trip will be issued with approximately 400 milliseconds, which is the Z2 trip time delay. Okay, 3B test case, which is the AR second fault after the reclaim time. So after the reclaim time means that the AR was successful. So in this test and the other test, 3A and 3B, the parameter which called reclaim time is tested. So the reclaim time starts with the final circuit breaker close command signal, and this time is set in our parameter setting in our example is setting to 3000 millisecond or 3 seconds. So if it's interrupted by a trip signal from a new fault incident, so the AR function will be plugged, and the timer is normally used to give the circuit breaker time to prepare for new AR sequence. Last but not least, AR with evolution of two-phase or three-phase fault. So in this test, we want to test the relay reaction to a fault evolving from one phase to a two-phase fault or three-phase fault. In our protection relay, the AR function is configured to block itself in case of detection of such an event. So it works with the single phase only. So it depends on the relay configuration, depends on the design parameter settings of the AR. You can test different kind of AR times, such as the dead time, the reclaim time, the action time, and you can define and simulate different test sequence for the AR function, as we explained here in the 6 test cases, by using the test universe 2 modules. Can be used by the AR dedicated module, and I have one video recorded for you in the Mastering Test Universe playlist. You can see it, how to test the AR using the AR dedicated module, and also it can be used freely using the state sequencer module as a generic test module. As we explained, you have the freedom to configure each state as you want and as desired. Also, it can be tested using the RelaySimTest software for a realistic simulation for the transient fault for all these test cases. So thank you everyone. If you have any question, please drop it in the comment. Thank you.